Hi, welcome to Code and Play. My name is Suman. So, in the last video, I showed you about composition and how we can use the composition in games, right? Um, Today, I'm going to show you a very interesting mechanic. The concept here is about Java programming, but the concept is little bit, um, I should say, mixed with real world, how real world gaming is actually works. So how real world gaming looks like. Okay, in most of the games nowadays we have a very interesting phenomenon called as microtransactions. So basically this phenomenon is nothing new, but we have a very rising problem in the industry. So the problem here is that most of the companies are um, favoring, most of the companies are like, you can say AAA companies or big companies that are making games are actually favoring microtransactions more over gameplay. Well, you can understand it is a good money making scheme, you can say. You can buy something, small things like boosts or skins in a game to like earn money and all that. So the developers will earn money, meanwhile the players will have fun. So it's a very good mechanic. The microtransactions is nothing bad, but the overuse of it is bad. So what if you want to also like, this is just like a like learning concept. This is not about teaching you how to use this. I'm just telling you that this behavior is bad. Okay, this overuse of something is bad. Even overuse of playing video games is also bad. So anything which, if you can control it, that is good. So today's concept is not about teaching you to do it. It is about telling you something that is happening in games, that we can actually see in games and learn something from it. Okay, like if you want to implement a specific mechanic in your game, how do you do that? So today's concept is about gacha games or gacha loot boxes. You know this very well in games like Call of Duty or like Genshin Impact, like games like many Western and Eastern games have this concept called gacha games, gacha loot boxes. What is the concept of this? Well, the loot boxes basically is a like part of a microtransaction concept, but added very like recently. Microtransactions has been a topic of debate for a long time, but the loot boxes concept came very recently. And on top of that, gacha loot boxes are even more. It's like taking the concept of loot boxes and making it into a random RNG concept. Okay, so let me explain what is gacha loot boxes. So what is a loot box? Basically, loot means something that is useful. Let's say you went on a raid. Okay, in D&D terms, Dungeons and Dragons terms, in D&D games, you go on a raid. You defeat a boss and you get a loot. Right? What is the loot? Loot basically means something that is um, used for progressing, like money, experience, or any item that will help you in future. So this is what loot means. It could be anything. It could be an experience, it could be money, it could be like the good times you spend with your friends playing video games or whatever you're doing in social media. Those are just like things that will help you in the future, in the next runs, or maybe it will help you progress in the game. Okay, so basically loot is a kind of bad term in real world, because loot basically means something that you um, what you say, um, that you acquired through burglary or theft, that is called loot. So it's not good in real world, but in game world you can say loot is something that you earned by doing some quest or doing some raid. Loot boxes basically means instead of doing all this, like going on a raid, defeating a boss, instead of doing all this, you spend money and get the same thing. So loot boxes eliminates this effort thing. Instead of doing all these things, you simply just pay money and get the same loot. That is what it means. This is why most of the people who are like playing these games, they don't like, or most of the people on internet don't like this concept called loot boxes, because they say that they have spent a lot of time grinding and all that to increase their level, get to the proper level, proper gear, and then someone just spends some money and they get the same thing. So it's kind of demeaning to them, right? And also there are some people who says like they have some disposable income, they just want to spend some time in game, just want to have fun. So it is kind of a debatable concept. Loot boxes is not something that you can easily say that it is bad or it is good. Loot boxes is kind of a debatable concept. You can say some people like it, some people don't like it, but if the game has it, then it's a feature. Simple. Okay. This is why many of the developers don't like, they like to add it, but there are also implications, positive and negative implications for adding a loot box mechanic in a game. Gacha loot boxes take this even more further. So instead of having a simple loot box, like where you know the outcome will be so and so, like a sword or a special character, gacha loot boxes will make that loot box into an RNG fest. So what is an RNG? Let me explain. This is a very interesting thing. So loot boxes. Let me give you an example of what is a loot box looks like. So let's say you have a box. In that you have some items. So this is a possibility of items. Okay, the loot box. If you open a loot box, you might get some items. You might get one item or multiple items. It's up to the developer who invents this, who like makes this concept. So in a box, let's say you have money. Okay, let's say 1,000 currency notes, and then you have some item, some in-game medium item, not too high level. It's like basic, better than basic and less than extreme. So it's like somewhere, you can say it's like a level 5 or 10 item. Okay, if your game has level 20 as the max item level, so you might get something like 5, 10, 15, like that. Okay, level 5, 10, 15, like that. So this is a medium item, a simple item that you can actually use it in the game to progress. And there might be some XP cards or some kind of shads that you can use, for example some magic crystals or something like that. Okay, so you have these things that you know that you, when you open the box, you know that you will get one of these things. Okay, there will be something that will be useful to you. This is called loot box. So if you open, for example, you got money, and on that there will be some RNG here. You won't get 1,000 notes, but maybe you get some 600 notes or 500 notes, like that. And you might not be getting the medium item that you like, or you can say the character item. Maybe you are getting a weapon item or an armor, something like that. Okay, so maybe you might not be having like you don't need that item. Maybe you get that item and then you can sell it to some other person and gain money from there as well. Like you understand the concept, right? It's a player driven economy. Player driven economies run like this. So one person spends some money on the boxes, they get something from the box, and then they can share it to other players or they can use it themselves. This is a common loot box. What about gacha loot boxes? Well, gacha loot boxes is actually very, you can say, RNG based. So what is RNG? RNG means random number generator. Random number generator. Basically, it means that you may get something or you may not get anything. That's what it means. Okay, RNG basically means you may get something or you may not get anything. Completely useless, completely empty. Not completely empty, but completely useless. So for example, you know that you will get at least 10 XP cards from this, at least one weapon or armor from this, and at least, like say, 500 to 1000 currency notes. Okay, so at least one of these things. So like 500 to 1000, or a one weapon, good armor, or 10 XP cards. You know that you will get at least one good item out of this. But in RNG, you have no idea what you're going to get. You might get 500 or you might get less than 500. You might get a weapon, you might not get a weapon. You may get a XP card, you may not get a XP card. Completely useless. So that box completely is useless. You can say that. So this is where gacha loot boxes are different. Normal loot boxes may have some conditions, like you will get this and this, or maybe this and this. You will get something useful. Gacha completely like eliminates the concept of chances. It's completely out of the box. You may get something, you may not get something. Completely useless things. For example, you get one currency note. I'm just saying, but it is just like that. Okay, you spend like $100 and you might get something good out of this, but in this, you completely just get scammed. Okay, and yeah, this is how it looks like. So RNG basically means like that. Basically, in these kind of games where you have gacha mechanics, people will spend a lot of money. So developers know that people will spend a lot of money. They design these systems in this way. They make the loot boxes and the systems in that way so that the people are forced to spend money. Those who are buying gacha boxes, they are forced to spend money. So if you don't want to spend it, you can play it without spending anything. But if you are spending, well, you will be stuck in a loop of gratification, instant gratification. Okay, so this is a kind of like say RNG is basically bad thing in the game industry. Most of the people say it is bad, some say it is good, some like it, some don't like it, some like the adventurous thing, the chances kind of thing, some don't like this thing. Some people say they enjoy this mechanic, some people don't like this mechanic. It's completely debatable concepts. Okay, so what I'm going to do here is I'm going to show you how you can actually design something in your game, or maybe I'm just going to show you how the games are actually using this concept. Okay, this is just an educational video. It is not about promoting anything. I'm not promoting any game or any mechanic. This is just an educational video to show you how this mechanic works. Okay, I'm saying again, this is not to promote any kind of mechanic. I'm not promoting anything. I'm not saying that go and buy something. No, no, don't do anything. Don't spend your money on useless things. Spend your money on your something that is worth to you. It will make, if you spend some money on yourself, it will be better. So if you want to learn something, like learn some techniques, like how it is implemented in the games, then you can watch this video. If you don't like it, just you can just leave now. Okay, so this video is an educational purpose, only to learn the programming behind it. It is not to encourage anybody. Okay, please play responsibly. Thank you. Now let's continue with this concept. Let's say how we can make a loot box mechanic. So first of all, to make a loot box mechanic, we have to take something into consideration. We have to say, like, let's talk about this kind of scenario where you have some currency notes, some weapon items, and some XP cards. So imagine you open the box and you get one of these items, only one. Okay, not multiple. For now, I'm not going to complicate anything. I'm just going to keep it simple. Let's say we open this box, this normal loot box, not gacha loot box, normal loot box, and we got one of this item, only one of this item. So how are we going to code this? How is it going to be made? How the program is made? So let's see how it is made. First of all, we need to understand that this is probability based. It is based on a probability. So what does a probability range looks like? Let's say you have 50% chance to get currency notes. Okay. The remaining 50% is divided in this way. You have 30% chance to get a item, game item. Okay. And you have like 20% chance to get an XP card. Okay. So if you want to like increase this or decrease this, you can also just adjust these percentages here. 50 plus 30 is 80, 80 plus 20 is 100. So total 100%. In total 100%, you have 60% chance to get currency, 25% chance to get a game card, or 30% chance to get a game card, and game item, or let's say we can say like this. Game item is very less. XP card is having like 25% to get an XP card, and how much is remaining? 15% for a game item. Okay, or let's make it even smaller. Let's make it 30 and 10. So 60 plus 30 is 90, 90 plus 10 is 100. So totally we have 100% chance of getting something, and out of that something 60% is currency, 30% is XP, and 10% is game item, something good in the game item. Is it recording? Yes, it is recording. Okay, so now if you want to do something like this, if you want to make a program that can execute a probability chance concept, well, most of the people know that we have a random class in Java, right? Even in Python, we have util package, or sorry, we have random function, math.random. So in this case, we have a random class, or you can also use in Java called math.random from util package. It's up to you. You can use any one of this, either a random class or math.random, any one of this. I'm going to use random class because it is like courtesy to when you're using Java programming. It is better to use classes. Packages, you need to learn more packages, learn more about the classes and packages that you're using. So I'm going to teach you this. You can also use math.random from util package, up to you. This is also in util. Math.random is from I think java.lang or something. This is from util. Util package is the most useful package in Java. It has so many things: scanner class, random. We also have a lot of things in util package. We'll discuss a lot of things in the next videos. So in this case, I'm going to use a random class, and this random class will generate a random number between 1 and 100. Okay, it will generate a random number. It will generate a random number between 1 and 100. I have to write a program where I should take this number and then compare the numbers here, the ranges here, either 60 or 30 or 10. So if it is 1 to 60%, that means currency, show currency. If it is 1 to 90% or 60 to 90%, then it is XP card. And if it is 90 to 100%, then it is game item. It's kind of like if you get a number, like 54, 54 is between 1 and 60. So you get currency. If you get a number like 68, which is more than 60, so you get XP card. If you get a number like 89, 89 is little bit less than here, I think 60 to 30. So you still get XP card. And if you get 91, you get a game item. Okay. So you get a random number from here. Based on this random number, I'm going to show the item to the user, whichever item is relevant. So to do this, we should use if else, else if. That's what we use in most of the cases, right? But in this case, I'm going to use a very interesting class called map. This is a class that we mostly use to store data. You know that. It is like this. You have a string, you have a string. So if you say name, then you say Suman. So this is the key. Key is the ID kind of thing, and value is the value of that key. You can say in a table, this is the column name, and this is the data in that column. Okay. So like this, we have data stored in a map. But in this case, I'm going to use a very specific kind of map. We call this navigable map or navigable tree. Okay, basically navigable tree map. So what is a tree map? Well, in maps, basically map is a class, is an abstract class. In Java, we call them modern variables. In primitive variables or primitive data types, we have int, char, float, and double. We also have long. We also have short and unsigned and all that. But I will also try to. I'm also including string into this primitive data types. Primitive data types basically are coming from C language. Okay, even though string is added in the C++, but still it is a primitive. It is already existing in the previous iterations before Java. In Java, we use a modern data type called as map, list, stack, queue, and also set, hash set, tree set, like that. So these are the modern data types, okay, which we use mostly in Java. We also have vector array. So we have these kind of things in Java. These are called collection classes. These collection classes are actually abstract classes. Basically, they have the methods that we want to use, and these classes are later extended into child classes. For example, we have array list. I have been using this array list since like from the beginning of the channel. I have been using the array list most of the times. So array list is a subclass, or you can say child class of list. How do we write this? We'll say list a equal to new array list. This is how we write, right? So this is how we mostly represent the list. Some people who know about this concept, they will say that this is how you write this, but there is a name for this. I think it is upcasting. It is upcasting, I think, where you are using a child class object and linking it to a parent class variable. Okay, this is an object variable. This a is an object variable, and this new is an object, and this array list is the reference. So this entire line is called creating an object. So how do you create an object? By using this line. And which object is this? The object is array list object, the child class, and it is linked to a parent class variable. So this is called upcasting. So in Java, we have upcasting. We also have downcasting. Downcasting is a little bit different. In downcasting, let's say we have class parent, or let's say parent, okay, P capital, parent P equal to new parent, and now I will say child C1 equal to child of P. So what does it mean? It means I am going to use the parent class functionalities from my child class object, or you can say the child class has been converted into a parent class object. Casting, type casting. Okay, this is called downcasting. So in this case, we are using the properties from here. That means the variables and functions from here. But instead of calling the P, I will call the C1 directly. Okay. So this is called upcasting and downcasting. So in this upcasting, downcasting concepts, most of the times we ignore what we are writing here, but actually this is what we are writing. This is a child class. This is a parent class. And in the case of map, we have like this map. Let's say let's just give a generic variable kv m equal to new. We have been using hash map. We know that hash map is also kind of map, but it is not based on any specific ID. It doesn't have any sorting mechanism. It completely just arranges the values randomly. So if example I said 1 comma, let's say m dot put 1 comma, let's just give this as integer and this as string. So in this case, if I say 1 comma Suman and m dot put 2 comma, let's say Sandeep. So what happens here is you will not have a guarantee that you will see 1 and 2. You might see 2 and 1. And if I add one more value here, let's say m dot put 3 comma Rahul. So there is no guarantee that you will see 2 3 2 1. There could be 2 3 1 as well. Okay, there is no guarantee that you will have any order. This is completely unordered. Hash map is a kind of way to store values, but it is not the only way. The only way is not there is no only way in Java, but we use them as we like. Okay, one such map is this navigable TreeMap. Okay, the navigable TreeMap is also similar to hash map, but instead of normal hash map, it has a sorting order. It sorts the value based on the number or a name. For example, in the previous example, I said m dot something, right? Let's put the same thing here. 1 comma Suman n dot put 2 comma Sandeep. So this time we are sure that it is going to always order them 1 and 2. It is an ascending order. It is a sure case. If I add one more value, like in the middle, if I add one more value in the middle, for example here I said n dot put 3 comma Rahul, automatically it will assign the Rahul at the end. This is a sorted list, sorted map. Okay, in case if you are not using numbers, you're using names, then what? Let's say you said the name first and then the number, like this. This is 3 and this is 2. Now what? Well, in this case, what it will do is it will see the first character. The first character is S, here R and again S. So in the alphabetical order, R comes first. So the first name will be Rahul. The next name, in the next character, you have U and you have A. A comes first. So the next character will be Sandeep and the next character will be Suman. This is how it arranges the value. Okay, you know for a certain that the navigable tree map will automatically sort the numbers and the names in your program. So it doesn't matter how you want to show it, it automatically swaps them, it automatically sorts them. Okay, this is the, like, it is one of the helpful concepts. If you want a sorted map, you can use the navigable tree map. Tree maps basically has a sorting mechanism. Tree maps are mostly used for these cases. Why I'm using a navigable tree map? Well, I'm going to use probabilities. That's why I'm going to use navigable tree map. Now let me show you the concept of using navigable tree map, or how probabilities work in the navigable tree map. So in this case, what I'm going to do is I'm going to add the code like this. 60, I'm going to say currency. Then the remaining one, the 60 to 30 is 90. At 90, I'm going to add, what is that? XP. Yeah, XP. And at 100, I'm going to add a game item. Okay. Now, whenever I draw a random number like 54, it will automatically sorts this value. So 54 is less than 60, so automatically it will say currency. It will say currency because I said navigable tree map. Because in the navigable tree map, the currencies, or sorry, the probabilities will be automatically matched. It will match the probabilities automatically. Instead of writing the algorithms yourself, you can use these concepts that are already available in Java. This is called as collection classes. Instead of writing everything on your own, you are using a library. This is why learning Java is not enough. You should know how to work with it. Okay. This is one of the concepts that most of the people don't know. Most of the times we just learn these things as a student. You just learn them like list, map, set, vector, stack, queue, and all that. But once you try to work with them, there will be things like this. There will be things like navigable tree map, hash set, hash map, tree set, all that. Okay. And also, for those who are wondering what is a set means, set basically is a non-repeatable group. If you have any duplicate values, it will automatically clear those values. It's like clearing the data. Like in data science, we say data processing. We gather the data and then we clean the data. We remove all the duplicates, we remove all the null values and all that, and then we have a clean data. Set is the most useful in that case. If you want to work with data science in Java, you should learn how to use sets. Okay, sets and maps and lists. Also, as well as we also have stacks and queues as well. But vectors are also used. Vectors can also be used. Now, let's see how we do this in a project. If you are watching still, thank you so much. Let's continue this code. As I said, I'm not going to encourage anything. I'm not encouraging anything. I'm not encouraging anybody to like gamble or anything. This is just a gamble concept. I know loot boxes are gambles. I know that. I'm not encouraging anybody to do these kind of things. I'm just teaching you how it is done. Okay, I'm just showing you how the loot boxes actually work. Actually, the code is written in a very interesting way. That's why I'm showing all these things to you. You can use this concept for something else, but I'm just showing it for in the case of loot boxes because it is more relevant in that case. Probabilities, choices, and all that. Okay, so let's see. We can also use this same concept for like boss attacks. In case of dungeon raids or in case of monster attacks, you can have a list of monster attacks and you can throw a dice and select a random attack based on the probability. You can do like that. Okay, the random monster attack or random boss attack, like that. So this is just a kind of example just to show you how it works. This is just a simple base example. Okay, so let's see. I'm going to say RNG, but I'm not going to write that because it's a very negative term. So I'm going to use loot box mechanic. Let's see, let's discuss this loot box mechanic, how it works and why it works. First of all, we need a class com.summon.game, and I have a class here, main class. Okay, this main class is built, main, right? System.out.println hello, and once you execute this, it should work exactly. Now what I'm going to do here is I'm going to show you how we do this. Okay, so let's see how to make this concept. First of all, we have to create a navigable tree map so that we can understand how do we execute this code. So I'm going to create a navigable tree map here. Okay, navigable map. You also have navigable set. As you can see, in the map concept, you'll see extended with, wait a minute. Okay, a sorted map extended with navigation methods, returning the closest matches for given search targets. Closest matches for given search targets. And the methods that we use here is high entry, ceiling entry, floor entry, lower entry. Okay, entry objects associated with keys respectively less than or equal, greater than or equal, and greater than a given key. Returning null if there is no key set, no such key. So basically what it says is, if you have a probability, okay, if you have a probability distribution like this, and you give a random number, it will give out the closest number to it. For example, if I gave 84 instead of 54, I gave 84, the closest number is 90. If I give like 95, the closest number is 100. Okay, like that. This is called higher entry. So by using higher entry method, I'm going to find out what is the closest number to it and return that item. Okay, this is kind of a like you can say RNG, but it is not RNG, it is little bit better RNG. I am not saying that I am going to not give you anything. For example, in this case, most of the times the RNG methods work this way. Like 50% of the time, you get nothing. You get nothing. Or let's say you get like 100 currency. Okay. And remaining choices like 10, 20, 30% like that. Okay. So gacha games are very bad. The reason because their probability distribution is not even. It is completely uneven. And adding RNG into that, it is even more uneven. Okay. Whereas loot boxes, the concept of loot boxes is this. Loot boxes basically have a mechanism where you have a probability, but you are sure that you only get those items. You surely know that you will get some items. Okay, something good like that. Okay, so let's say navigable map. So navigable map is similar to a hash map, but instead of using hash map, I'm going to use a navigable map. It looks like this. First of all, I'm going to use integer for the probability part, and the next part is a string, or in case if I'm using game item, I'll use a game item object. Okay, if I'm using an object called game item, I'll be using a game item, but since I'm not using game item, I'm using a string. just to execute a simple loot box mechanic, just to show you how it works. In your games, you can use game items in case of in the place of strings. Okay, so let's say navigable map. Okay, navigable map is kind of a tree map, so we use a tree map. Okay, so now I'm going to use some items, put some items in this. Let's say 60% is currency, map dot put 60 to 90% is XP. This is also string, and map dot put at 100% you have a weapon, unique weapon. Let's say a unique weapon. So this is our map, right? Now what I'll say is, instead of just to show you how it works, if I say map, you will see a sorted map. Okay, 60, 90, 100. So now if I say map dot higher entry, higher key, let's say 50. So the closest number to this is actually currency. So higher key is this. You will get the 60 part, which is this. The higher key is this. Okay. Now, what if I use higher entry? Instead of higher key, I'll use higher entry. If I use 50, I will get the value of it, the complete set of it, 60 currency. If I say 85, the closest is XP, so I will get 90 XP. If I say 95, the closest is unique weapon. Understand? So now just to get the value, I can simply just say get value. So what is the value? Unique weapon. What is the value of the number like 55? It is currency. Okay, simple. So we have a number here, we just give the number, and whichever is closest to it at the highest level, it will automatically get the value of it. Now, just to simulate this concept, just to show you how it works, or how the loot box mechanic works, I'm going to use a random number, RAND, random number equal to new random. Okay, this is a util class. It is from util class, util package. Sorry, util package. Now, first of all, let's see what the random number will be. Next int. I just want a next int, and I said 100. Okay, next int 100. Let's see what we get in the output. What we got? 32. Once again 92. Again 20. Again 88. So it's a random number. It's a random number every time. Now we take this number. Okay, we take this number, int r equal to rand dot next int, and then we execute this number here, map dot higher entry r dot get value. Simple. Now when you execute this, you get the currency. If I execute again, I'll get XP because the higher entry is more. So to see the random number, let's print the R itself. Okay, so let's see now. 73 XP because it is closest to 90. 25 is currency because closest to 60. 57 again currency. 60 is XP. Why XP? Because it is I said less than or greater than. There is no equal to in this. The reason is why it said XP is because If it is less than 60, then it will show currency. If it is greater than 60 or equal to 60, it goes to XP, the next value. Because I said higher entry. So higher entry basically means the next value, higher value. Okay. 2 currency, 27 currency, like that. So if you want to use a loot box mechanic, you can use this navigable map in your games. Create a probability distribution like this and you can execute this. Okay. So if you want to add more items into this box, you can also add more items into this box. Then you have to distribute the probability according to that box, right? So you can also add one more RNG in the case of currency or XP. For example, I got the value, I got the higher entry value, like string item equal to map dot higher entry r dot get value. I got the value. Now I'm also checking if it is like, for example, currency or XP. Okay. So what will I say? If r less than 90, less than 90 basically means either it is a currency or XP. If it is a unique weapon, then it is nothing. We don't use this mechanic anymore. Okay. Less than 90, then what will I say is I want to show one more value called C, count. Okay. RAND dot next int of, let's say I want to give 500 value, just a value 500. Okay. But let's make it 1000. But I also want to give a minimum value. Minimum value is 100. Let's see what we get now. So in this case, if I show the R and the value which is item, okay, instead of writing it here int C, I should declare the C as 1. Int C equal to 1. Initially C is 1. Now depending on this value, the C value will change. So C plus item plus C. Okay. So instead of doing all this, we can also format this. I'm saying string dot format. Okay. So what is the value? First we will see the probability, then we will see the number x s. X basically means number into value. It's like 1 currency, like that. Okay. There is no significance with this x. This is just a placeholder. So this percentages. The first value is R, second value is C, third value is item. So this is how our string format works. So let's see now. If I execute this, you see 47, 700 currency, 519 currency, 21, 519 currency, 500 currency, 987 currency, okay, 794 currency, like that. So you have one unique weapon. Interesting, right? As I said, less than 90, then you apply this mechanic, or else C is equal to 1. So C is 1. So if I go again, 638 currency, 755 currency, like that. Okay, 894 currency, 183 currency, and if it is this, 387 XP. You can also add different numbers here. You can create different thresholds. For example, say instead of saying 387 XP, okay, you can say like 10,000. In case of XP, you have a different number, and in case of currency, you have a different number. You can also write in that way, else if else kind of thing. Okay, I guess you understand the point. So if you want to add more into this, you can also add like else if like that. So in this case I'm using currency is between 100 and 1000, and xp is between, if it is less than 90, then it is c equal to rand dot next int, it is less than like 10,000 to 1000, like this. Okay, so in this case, yeah, xp is 8126 xp 73, and in this case 29, so currency is 947, 521 currency, again 2769 xp. Okay, so like this you can make something out of the code. So this is called navigable map. Navigable map basically is a probability distribution map where it will store the values as probabilities. If you are using it in this way, it stores the values as probabilities, and it will give out the higher entry value, the highest entry value, which is the value that is closest to it, okay, based on the number that we gave. So if the number is a random number, you set the random number and it will automatically give out this way. You can do this for boss attack patterns or monster attack patterns. You can create a navigable map for a monster and you add some attacks in that. Let's say you have a pummel, you have a slam, you have a special attack here, and whenever there is a higher probability, the special attack will apply. Most of the times it will just pummel you, and sometimes it will body slam you, like that. So you can create a kind of probability distribution kind of thing. Okay, so this is a way to use the classes that we already have in Java. I'm not saying anything new, I'm just showing you how it is done. Okay, so this is kind of a loot box mechanic concept. You can create something like this in your game and you can use it. Again, I'm telling you, I'm not encouraging anybody to go and do this. I'm just telling you how it is done. If you learned something from this, that is good. Learn to use more and more techniques like this. Okay, so instead of wasting your time writing all the mechanics and probabilities and everything, you can simply use a tree map, navigable map, and just use the predefined code. Okay, just to make yourself just to make the program that you wanted to write easier. Java is not all about writing programs from scratch. It is about using the program in a way that is useful in the real world. It is just like Python. Instead of writing everything from scratch, you also have packages in Java. Most of the people don't use that because people like people who are using Java, they are kind of a nerd kind of thing. They like to do everything on their own. It is not a bad thing. It is good. It is good to do everything on your own, but it is also better to learn some things like this. Okay, sometimes it is good to know that Java also have these facilities, not just Python. Java also have packages, predefined codes. This is it for today. I know this is a very short video, but I just want to show you this mechanic, and also I want to clarify some things about Java and everything. Some people who has this perception that Java is all about writing lengthy programs. No, it's not. It is the way that you're taught. It is not the way that is written in Java. Java also have short form programs. Like you also have a package concept. For example, I wrote this program for a loot box mechanic. Now I want to write the same code for dungeon mechanic, like progressive dungeons. For example, in case of like generative dungeons, map generations, you want to create a map generation where you have probabilities, and based on the probability, the map will have either a boss or a empty room or some kind of puzzle or something like that. So you can create a progressive map where you progress, and as you progress to the next room, the next few rooms will open up, like that. You can create something using these techniques. Okay, so you learn something here and you then use this concept somewhere else. Java has this facility. So this is it. This is what I want to say, what I want to show you. This is for today. I hope you learned something new. This is very interesting. Most people don't teach them, or most people don't learn this in the colleges or schools. So this is all learned on your own. As I said, Java is also all about writing programs efficiently, not just Python or not just .NET or not just Dart. Java also has this. So that's it. I hope you learned something new from this. Thank you so much.